I've started building a small animation framework for myself, and I want to discuss how I made this animation. There's going to be a long form video where you can see me actually work through developing it. This is the short form for those that just are interested in how does this actually work. We'll just walk through the code. And for those that actually want to see how to develop something like that, you can check out the long form video. Right. Let's get to the code. So all this is just this animated box here, and this animated box is just a higher order component of a box, and we then specify the properties we want to animate with some rules. The box itself is not that exciting. It's just a box that takes 3 parameters here, angle, x and y, and then just applies a transformation over them. If we look at the class itself, it just positions a box in the center with a border, and that's really it. So the interesting part is this with animation props. Now there are 2 parts to this. There's this higher order component, and there is this animation hook here. This is the actual part that does the heavy lifting of the animation. So what happens is that for every specification in let me set this up. So for every entry here, every one of these will be animated with this hook essentially. And it'll set a state based on the update rule here. So where's the draggable thing? So we'll be running through this. We'll start with some initial value, that is the value over here. And then we have some way of updating our rules. This is the update rule specified here or here. If we look, let me close this thing over here, have some more space. Like our update rule here, for example, is just the previous state plus the time that elapsed as our parameters, and then we just continue our rotation based on, this is rotations per milliseconds, based on how much time has passed, the delta. And then we wrap around to 0 once we've completed a full rotation. And here we can see we're using the request animation frame. The reason we're using request animation frame is because this allows the browser to optimize the actual animation. If we wouldn't use it and use some set timeout or something, we'd see some stuttering in the browser, and the browser would really hate us for what we're doing. Also, this allows the browser to just conditionally render. For example, if the tab isn't open, then it just won't call this. It is also nice to the CPU of the client in the end. So what does it do? It has just for every frame it does run this function, and if we haven't run before, then we're just setting the before to the actual now timestamp here. We compute our delta, which is just the difference between now and before. We set our before to the current now, so that in the next frame it's going to be the previous frame's value. And then we just set the state based on this update rule, and we reschedule the next animation frame. So animation frame is just one frame, it isn't actually a loop. And should the component unmount, we'll cancel animation frames. We don't want to keep doing this forever. And the configuration here is done with a higher order component. You could use, or we could use the hook directly, but the component makes it a bit nicer. We can define it. We can define it dynamically as well. We don't have to hard code these. We could, for example, have a JSON file that would specify all elements we want to animate with the type, and then we could generate from it all types of elements and animations based on that specification. This is what would allow us to do that. So if we look at the actual with animated props, it takes this specification in. This specification is just a mapped type, a partial mapped type, because these are potentially undefined, of this shape. This is in here in case we want to allow more other types of animations with other types of properties in the future. Like I said, I'm trying to build a small framework for myself. I'm not sure about it yet. I might refactor it all. But it has a initial value and a update rule. An update rule is nothing else than just a up here a state and a delta that maps to a state, because an animation is just a transition of states over time. So it takes this type of animated in, and it returns a new functional component. That's just a functional component here. The definition just makes it easier for me to work with it, but just think of a functional component here. And it then sets the new properties to the old properties, except those that have been specified. So if we didn't specify the y value, for example, here, then we'd get an error down here that y has not been defined. It's missing. We see that also in the browser. Property y is missing. So we'd need to define y now to some value, 0 for, let's say 0, for example. And when we'll get a side-to-side animation. Let me undo that. Sorry. Right. This is what allows us to animate. So how does this actually work? So we're going through the animated object keys that we get here through entries. We extract all the defined ones. I just said they are possibly undefined. So we extract all the defined ones. And then for every defined one here, we turn it back into a property object. So this will then look of a shape of property computed value of this shape. And we are just calling the hook here. Yes, this looks like conditioning calling of hooks, but this is hard-coded and included in an enclosure. Like this order can never change inside this component. There are methods of getting rid of this warning other than just saying ignore it. But in this case, this is enough. So we create our computer values for each property. And then if we encountered some type of specification, we technically can't because TypeScript won't allow us to. But if we encounter any such thing, then we can throw an exception and say this is not a recognized animation type. And then we just feed in both the animation props and the original leftover props in and return that as a wrapped component. That is all. There is a utility function. If we look in the browser here under components, that is a nice thing to do with functional higher order components. If we look at our actual type of the higher order component, it has this with animated props here now and says the new what type it's wrapping. So this is what this display name setting does here. What this setting does here, it makes it nicer for debugging. So we extract the old name, we set the new name. That's all it does. Now, there's one more piece of interesting code here, and that is this update with state. And that is animating the X position is not a direct state. We want to know where in the circle we are, since we're using cosine. So we want to know where in the circle we are, and then translate to the actual X position and offset it, because this is a very small value. We wouldn't actually see anything otherwise. So we need to somehow decouple our state from our property. And that's what this update with state does. So if we look at it, all it does is it takes an initial state, also an update rule that is for the update rule for the state, and an additional mapper that transforms that state back into a into the type of the property. And then we just use closure to capture our initial state, the current one, so that whenever this function runs multiple times, because that's the update function that then we provide. So whenever this function runs, it has access to the previous state. So it can update it every time it gets called with the rule, with the update rule, and then returns the mapped value. That is all we need to do animations. I'll be extending this with more interesting animations in the future. If you've got any questions, if you want me to explain something, leave a comment. If you like what I'm doing, you can subscribe or not. It's up to you. And see you around.